Okay, guys. So today we're going to see about deep learning. So before deep learning, so you people are already know what is deep learning. Just guess something. So what is deep learning?
Knowing deeply about something, like having some more knowledge. Just
Sorry,
guess. Not sure about it.
Alka. So if we are toddler, so you have to assume that if we are toddler, how we
Hmm.
people are learn the small objects like apple, orange, ball, bat, cat, dog. How we people are understand.
We observe the things like first we see, then listen to the people, then
Yes, so
observe.
every object has a shape and the size also and color too and pattern also, right?
Hmm.
So cat and dog has also pattern, a shape, a structure, right? And we have the sizes of apple also have size and shape is different, right? So if it's like a apple is like a size of watermelon. So have you confirmed that it's a apple? Yes, guys.
Hmm.
No.
No. So if the apple is in size of gooseberry, have you taken as an apple? It's possible?
No.
No. So it has a structure, right? So it has a shape and size and colors and patterns also. So guys, assume that. So in deep learning concepts, I will give one example like a Google Lens. So we are using Google Lens, right? So if you are taking any pictures on your Google Lens, so it automatically detects the object, right? So either it's a dustbin or pencil box or mobile or laptop or any other electronic devices or any fruits or vegetables, anything. Have you heard? Yes, guys. So the best example is our Google Lens. So it's automatically get the input. So the first one is the input layer. So you directly seen the output, right? So that is called output layer. But the hidden layer, we people are don't understand the what is hidden layer. So it is a computational layer. So it automatically compute the image process, so it understand the image size and shape and color and pattern also. So have you taken as if apple is in raw red color, so full and full is red, have you taken as apple?
No, not fully right.
Yes, so it has some patterns, right? So it's like yellow or orange or red or something pattern, right? So that process will happen in hidden layers. So guys, assume that so the first one is I take as a, so we are children. So I give first image label as a apple. So I taken as a x1. So it's a apple image and x2 as the orange image. So it has weights, guys. So it has a weightage. Okay, so weightage means it has a 0.96 means 96 percentage, 0.88 88 percentage, and it is a 7 percentage, and it is a uh, 99 percentage. Okay, so we will see the weightages. So we will see the weightages if it which one is highest. So guys, in hidden layer 1 2, any requirements will be there. So maybe it's in color, RGB color, red, orange, like that, orange or yellow or green. Okay, so guys, it may have any features or colors. Hidden layer may contains colors or shapes or size or patterns or anything. I just give an example: hidden layer 1 and hidden layer 2. So it may check the computation, finally it predict the output, finally it predict the. So guys, here the weightage is 0.99, here the weightage is 0.67. Which one is highest? So now tell me which one is highest, 99 percentage or 67 percentage? 99
99.
percentage. So it automatically predict as a, so our output is what? So Apple, if you given as an input on a Google Lens, it automatically compute the process in hidden layer and we will get the output in the output layer. Have you got my point, guys? So this is the three layers which we are using in the deep learning concepts. Have you understood? Yes, Alka and Gautam.
Yeah.
Okay. So guys, we will see on the concept in deeply. So just see the concept. So I already told, right? So it's a deep learning is a machine learning part of machine learning, right? So I already drawn the diagram, subset diagram. So AI and the subset is machine learning, and the subset of machine learning is deep learning, and the subset of NLP is what? Deep learning. Okay, so deep learning is the part of machine learning and it's mainly using for the neural networks with multiple layers, right? So here the multiple layers are present in the neural network, right? So these are the network layer. So I given as a arrow mark. So this is the network layer. So then only is neural networks with multiple layers. So it learns the complex patterns. So complex patterns mean it identify the pattern shape, colors and sizes. So that is called complex patterns. And what are the data we will give us means we will give as input images or text or audio or video. So it's automatically learns the data, guys, so without manual feature engineering. But in machine learning concept, we need human manual feature engineering we will need it, but in deep learning part we no needed, so we will directly automatically learns without feature engineering. Have you got my point? So we are using face recognition in our mobile phone, right? So face lock. So it's also one of the deep learning concepts, and speech to text virtual assistant. So we already used in our WhatsApp, right? So if you are speaking anything in our mic, so it automatically converts as a text, right? Yes. And it's also used for tumor detections for medical images. It automatically find the cancers. So that means tumor detections. So and another best example is X-rays, right? So X-ray is one of the deep learning concepts. It automatically learns the bone structures. Have you got my point, guys? Have you understood what is deep learning? Is what happened?
Yes. So where we
Yeah, we
need
will
to
give us an image or else we will give us a text. In our Google Assistants also have speech recognition, right? So it automatically takes our speech and convert it into a text. And audio also. We will remove this. So you can take any song and player. So you can remove as a individual karaoke individual and song also individual. You can take in as the line, right? So or else we can use as a video also for so in our traffic roads. So there are many sites. The camera will fix, right? So it automatically detects the bike and helmet also. If anybody is not wearing a helmet, so it automatically give a
okay.
fine, right? So it automatically put a fine, right? Yes. So this is the rules. So just listen. First, the process is data collection, and the next one is pre-processing, and the next thing is free feature engineering. So I'll tell you. So what is feature engineering? So guys, you people are already know. So data collection, we will gather data from any files or databases or any sensors. So here we can using SQL or web scraping or APIs or any other IoT devices. And so in pre-processing, you people are already known, so pandas and numpy, these concepts. So we can with the help of these tools, and we will cleaning and handling the missing values and removing noises. In feature engineering means we want automatically convert as a label encoding. So label encoding, one hot normalization. So in deep learning part, it automatically works, guys, okay, without human. Okay, so then only we call it as a feature without feature engineering. So and another one is modeling. So modeling, so it's build and training the machine learning and deep learning model. So I already told, right? So in machine learning we are using scikit-learn, and in deep learning part we are using in the TensorFlow. So we will see the TensorFlow in deep learning concepts, okay? And the evaluation metrics also here we are using. So for classification, so we are using for accuracy and precision, recall and F1 scores. These are the tests for deep learning performance. And finally, the deployment, we will use Flask or Fast API or AWS or Docker to deploy our applications. Have you got my point, guys? So this is the pipeline of deep learning. So have you got my point? Yes, guys. Okay, so let's see. So the next topic is structure of neural network. So I already told, right? So first one is input layer, and the next one is hidden layer, and the last one is output layer. So input layer means so it accepts the input features. In hidden layer parts, it performs the computations or transformation, and in output layer, so it produces the final prediction. So this is the guys. This is the structure of neural network. So it automatically gets a input and with the weights, so it calculate the weights, so multiply and the summations, and finally with the help of activation function we will split the data into output. So in activation function it may be sigmoid or softmax or any other thing. You people are already know in sigmoid. So what you people are doing in sigmoid? So sigmoid have ones and zeros. It only returns are a positive or negative value, true, either true or false. Have you got my point? So this is the formula of activation function. So guys, have you got my point? So you people are already know. So the image read function. So you just given the image as a PNG format. If it is image show, it automatically shows. We just off the access and the title is neural networks. So it plot will be automatically shown. Do you have any doubts here, guys? Is So feed forward process means so it's in a left to right process. It means first one is input and weighted sum and applying the activation function, and the next one is what output layer. So this is called feed forward. So it means data flow is in a one way, right? So input to output, right? Left to right. Do you have any doubts in feed forward process? Is
No, no.
Okay. And the next one is activation function. This is I already told several times. So this is the functions. So ReLU means rectified linear unit. So its output range is 0 to infinity. So it's mainly using in hidden layer. And you people are already know sigmoid is used for binary classification. The range is 0 or 1. And tan H the range is -1, 0 or 1. So this is for used for centered activations, and softmax we are using. So it may have any number, guys. It's some one. Okay, some one means it automatically gets us a 0, 1, 2, 3, 4, like that. So this is called multi-class classification, and leakly relu is used for minus infinity to positive infinity. So this is called allow small gradient for negative values. This is allows negative values, and this only allows the positive values only. Okay. Do you have any doubts in activation function?
So these are the limits, or you can say the range.
Yeah, yeah, yeah.
One of the function has a one of the range.
Yes, yes, yes. We will see one by one. So the next one is a loss function. This is the function we are anytime use. Why we are using this mean squared error? So this is mainly using for regression to find the loss function, and the mean absolute error also same thing. And Huber just okay, just read it. And the next one is binary cross entropy, categorical cross entropy. So this is we are mainly using in our use cases. So this is for binary classifications, and categorical cross entropy for multi-class classification. It automatically convert as a one hot labels. It means ones and zeros. And sparse categorical cross entropy, and so just read it out, guys. Okay, we have more loss functions are there, and here we are using some a few loss functions only. Okay. And the next one is back propagation. So back propagation means, so we will travels in one direction, but our output is wrong. So if it is your output is not predicted well, so you just go to backtrack and change into update the weights. You just update the weights, and again the flow is comes if the output is will be predicted perfectly. Have you got my point? So that's called a backpropagation. It calculates the error and update the weights using gradient, then only repeat the over the epochs to reduce the losses. Have you got my point? Have you understood what is backpropagation? Okay, so the next one is optimizer. So the optimizer is using for reading purpose. So we are mostly using Adam only, guys. You just know the concept: stochastic gradient descent and root mean square propagation. So you just differ it. So this is a simple and slower convergence, but and it is great for RNN. So widely we are using this only, guys. It's easily adapt and very faster. So then only we are using optimizer as a Adam optimizer. We will see in our code, don't worry. Have you got my point?
Yeah.
Is okay. I'll show you the I will show you the encoding. Okay. So and batch normalization. So batch normalization means while we training the data and speed up the training, so the data will unstable. So the learning is stabilized learning. So the output shape will never change. The output shape is never change. So it will get from the input. So it means so in my WhatsApp I am sharing a pictures. So in same HD format. So you can view also your WhatsApp also. Have you got my point? Same quality without any quality reduction. Have you
So,
have
sorry,
you noted
can you
down?
please repeat that example?
Yes, so if so in previous time, so we are sharing the photos like from iPhone to normal mobile. So the photo quality will be changed, right? High
Yeah.
quality to low quality. But in batch normalization, if you are sharing the data, so the training data will be stable. So it reaches the entire data perfectly without any reduction.
In image quality.
Yeah, I'll just
Okay.
give the example. The same concept we are applying in deep learning concepts also.
Okay.
Is and the next one is dropout layer. So the dropout layer, while training the data, it automatically removes the neurons. So while training, so guys, uh, so here's the orange is no needed, right? So in Apple, here the orange is no needed, right? Is
Yes.
the orange and yellow, right? So while training the data, it automatically removes the data. It automatically removes the data while training the data set. Okay, I just give the example, right? So dropout layer means it randomly gives us an input as a zero during training. Okay. Okay. And the next one is regularization techniques. So regularization techniques mainly we are using for preventing overfitting. So because in our image has noises and blur, there are many issues on our image, so that is called overfitting. By adding penalty to large weights in the model, so it automatically gives us a large weights for every model. Okay, so guys, assume that so the system will learns from automatically, so not directly. So it convert as a matrix. So it convert as a what? Matrix. So 3 cross 3 matrix. So each and every, this is a 3 cross 3 matrix, and let's see 0 0.97, 0 0.8, 87, 52, 25, 100, 101, 102. So let's see the matrix. Have you seen? So guys, we call it as matrix. So this is called Matrix or kernel. Okay, kernel or filter. Have you got my point? Gautam and Alka. Guys, we will not directly take as a image, we convert as a matrix format. So the format we call it as filter, we call it as filter or kernels, we call it as filter or kernels. Have you got my point? So the padding area will be 0. The padding area will be 0. But if the image it presents, it automatically shows as a point. Have you got my point? So guys, if you are reading the image, you people are only taking image or the background. So the background is called
Background.
padding. The background is called padding. Have you got my point, guys?
Yes.
Is See, regularization technique means it preventing the overfitting because the image has maybe noises or additional background. So these are the called overfitting. So using these techniques L1 and L2, so it makes weights as a sparse and it reduces the large weights. Let's see, no regularization means. So imagine that so this is the apple image. So this is the apple image. We are convert as a numbers. We will convert as a numbers. So here all weights are active. So here all weights are active. So in L1 regularization, so many weights are exactly what? Many weights are exactly what? Zero.
Zeros.
Okay. So but L2, so all weights are non-zero. Okay, non-zero, but all weights are what? Reduced. So all weights are reduced, right? So guys, compare the first matrix and last matrix. So the weight will be reduced, right?
Yeah. In
Hmm.
row 1, column 4, 151 to 140, 155 to
Yes.
141.
Yes. Have you got my point?
Hmm.
Okay. So just to see the differences. No regularization means all weights are active. L1 means it will gets as a 0. Many weights are gets as a 0. While L2 it's a non-zero. So non-zero means it's never 1, 2, 3, 4, 5. So it's in zeros, but it weights are reduced, right? So string gauge means short. Okay, short means abstract. We call it as also abstract. Short the weightages. Have you got my point? And next one is hyperparameter tuning. So this is while we are using for before training the model. So it affects the behavior of learning. So let I tell you. First one is learning rate. We will give the learning rate and the epochs and batch size also, and we will give dropout rate for regularizations and layer neurons for new network architecture. I will show you the coding part. You just see the coding part. Okay. So guys, just remember, so here I given the data sets from breast cancer, and model selection I'm using for train test split, and pre-processing I'm using for standard scalar. So in the Keras models I'm using the sequential and dense, and the layer is input layer, and optimizer I'm using Adam and the pandas. Okay, I'll tell you one by one. Just imagine. So first we have to separate the datas, guys, X and Y. First we have to separate the datas. Okay, just load the breast cancer data set function. So if you given data, so it automatically give us a input, and so which one is independent, which one is dependent one, guys? So tell me now, which one is
X
dependent,
is
which
the
one is independent?
independent.
X is the independent and Y is the dependent. Okay, just to see, I given as a data frame. So given the data, and column name is feature names, it automatically comes. So mean radius, mean texture, mean perimeter, these are the things. So just to see, I given as a target function is called target variable. So this is the y. So it is the dependent variable, and these are the things are what? Independent variable. I just convert as zeros as a malignant disease, one as a benign disease. So it's a binary classification or multi-class classification. It's binary or
0 and 1
multi-class.
binary.
Is zeros or ones a binary classification, right? Have you got
And
my
mean
point?
either malignant or benign. Only
Yes,
two
yes,
cases
yes.
are there.
Yeah. We just mapping as a zero as a malignant and one as a benign. Have you got my point? Yes. And let's see another one. So here we are using the scalar, standard scalar functions. So this is the scalar object. We just fit the transformer object. So we just fit on the x and it automatically converts as a scalar fit transformer. You can just see the output. We just give us a x to see the output, guys. So let's see. So these are the values. So these are the values will convert as a what? Scale value, standard scale value. I think the value should be in -2 to 2, right? So this is the scale value. Have you got my point? So in this row automatically converts as a what? Scale value, standard scale value. Have you got my point? Yes. So then only machines can understand. Have you got my point, guys? Yes.
Yeah.
Okay. And the next one is a train test speed. We are train and testing the model. So the 20% of data will be going for testing. And the random state here we are using the 42, right? So this is the model building. Just imagine that, guys, first you people understood this diagram, input layer, hidden layer and output layer. Okay. So let's see. So here we are using the sequential function. Now we are adding the input as a shape 30. So now tell me, so how many columns are there?
31.
31. So 30 columns are input and one column is what? So one column is a output. 30 columns are input and one column is a output. So the shape is what? 30. The shape is what? 30 comma. So 30 comma means the 30 neurons. I will draw the diagram. Just guys see the diagram. I'll show you. Okay, just see the diagram. So this is the input layer. Input layer has 30 neurons. 1, 2, 3, 4, 5, 6, up to 30. Have you got my point? Yes, this is the input layer. We will just give us a code, guys. So you have to assume that the image. Have you got my point? This is the input layer and the dense. So dense is fully connected. So fully connected layer means what? So fully connected layers. So it connected as a 16 dense layers. So here we are applying the activation is ReLU. So what is the range of ReLU? What is the range of ReLU? Is 0 to infinity, right? Okay, so all the layers will connected as a 16 dense neuron. 16 dense. So here we have 16. So here we have 30 neurons. 30 neurons. So this is called hidden layer 1. So this is called hidden layer 1. And now tell me, so what is the hidden layer 2? So it connected as a 8, right? So it connected as a 8 neurons. So we just draw the 8 neurons.
So from input layer 1 to 30, each and every neuron is connected with 16 hidden layers and 8 hidden layers. Huh?
Yes, 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 yes.
Each and every node contains this kind of structure.
Yes, yes, Gautam. We can give like that. So 16. And finally the output is what? 1. So all the layers will connected as a single output, right?
Correct.
So you can just assume the images. It's enough. in this image is enough. I just give as a hidden layer as a 4, here hidden layer 2 as a 4, right? So it predict the output. So just see. Have you understood this model? How to build the model? So here we're using sigmoid. So what is our output? So what's our output? Sigmoid, either so malignant or benign, right? So this is the binary classification, right? So then only we are using the sigmoid. Have you got my point? Is finally, we will compile our model. So the optimizer we are using Adam function, and the last we are using, why we are using binary cross entropy loss. What why we are using here? So we are taking binary classification, right? So in matrices we are checking the accuracy. So here we are fitting the X train and Y train model. So the epochs is 20 means, so it automatically takes us each and every epochs for 20 times. So okay, so one epoch means one iteration, guys. Okay, it trains once. Okay, how many times it will trains? How many times it will trains? 20 times. Okay, so if I take a mark as a one time, so what did happen? Same question. Okay, same machine learning concept. If I am taking the mark, what did happen? So your accuracy maybe have 55, so your loss maybe have 70 percentage. If I taken 20 times on individually taken, so what is the output? Accuracy will be 98 and the loss will be what, 5 percentage, right? Is the batch size is 16, guys. It framed as a 16 as a batch. So you had to assume that. So in our science practical lab, so only 20, the batch size is at 25. The student strength is 100. Now tell me how many batch students will become there. The batch size is 25, and how many batches will present?
For each and every epoch, 25 will be present.
Is so batch sizes are 25, so we have 100 students, so only we have 4 badges, right? So same concept here. Here we have 29 badges. Here we have 29 badges, but in our science lab we have 4 badges, right? So it's a 29. So what's the single batch size? What's the size of single batch? So 16. What's the single batch of size? 16, right? And the verbose is 1. So verbose 1 means it automatically shows the green line. So it loaded. Have you got my point, guys? Adam, binary cross entropy, matrices, epochs, and batch sizes and verbose. Have you got my point? Yes. And finally, we will check our using evaluation metrics. We will check the accuracy. The accuracy is 98 percentage. Okay. So guys, this is a deep learning concept. You just do the coding and take the notes. Kindly revise the concepts. Okay. Do you have any doubts, guys? I can't go them. Do you have any doubts in this deep learning concepts?
No, Sam.